Okay, so this is kind of a quick review video here. So there are three methods. There's the graphing method to solve. Three methods to solve. Graphing method, there's substitution. When we're substituting, we want either x equals something or y equals something, and then we can substitute. And then there's the addition method. We need one variable to eliminate. And the good news is you can multiply by whatever you want. Okay, so that's just kind of a recap of the three methods. In theory, you could use any of the three methods to solve a system of linear equations in two variables. We don't generally use the graphing unless they specifically ask us to, because it's pretty inaccurate. You have to have everything just perfectly graphed, and and you could have a weird answer like 11 halves. Like that might be hard to read off a graph. Okay, so usually we're going to use either substitution or addition. I would use the one they tell me to, or if I get to pick, I pick the one that I think is going to be the easiest. Okay, just along with this little review though, there are three cases of answers. There's independent, an independent system. Hopefully I spelled that right. Independent. Something doesn't look right. Independent. Yeah, okay. So I can't spell. That's why mathematicians abbreviate everything. Independent. Okay, so an independent system, one line goes like this, one line goes like this. They intersect in a point. That point of intersection is the solution, whatever that point is. Inconsistent. An inconsistent system is where the lines are parallel. Lines are parallel. No solution. Now, just remember, no solution. Parallel lines have the same slope. So if you were finding the slope and you saw they were the same, you would say, oh, they're parallel lines, no solution. These are systems that we're solving, so we need like an answer. We need a solution. Okay, if there is no solution, we have to say no solution. Okay, and then there's the dependent system, which is a line, and then it looks like another line, but it turns out it's not another line. It's really just the same line. And so what happens is it's just the same line. And you might say, how could that happen? Well, let's say you had x plus y equals 5, and then you had 2x plus 2y equals 10. Well, see this bottom one, if I just divide everything by 2, I'm going to have the top line. So they aren't really two different lines. They're really just the same line. And so the way we write the answer, there's an infinite number of solutions, in case they ask. How many solutions? Infinite number of solutions. And they might write it like this. It's the set of xy such that x plus y equals 5. You would pick the one with the smaller numbers. Okay. That's just an example. Okay, so that's a review of what we've got going on these systems of equations in two variables.